Okay, so back to the model. I realized things are a bit dim here. I took a break. There we go. So as I mentioned, we have to. So the producers in the model, they basically have to guess what is the relative price conditional on observing only their own price and not the average price level. So how are they going to do that? Well, we've just argued that the best guess they can do is this object. Okay. So what we're going to do is we're gonna roll all these guys into a parameter b. Okay, so what's the supply going to look like? It's going to be b times the own price level minus the expectation of the average price level. Okay, so here it is right here. And I say here averaging, we get the Lucas supply curve. Why is that? Because on average, the quantity that's produced is just the average output in the economy. And then on average, the price level, the own price level, is just the overall price level in the economy. Okay, so this is the Lucas supply curve. Let's not cross it out. And what it says is, let's see here, it makes a relationship between output and price. And it says that the higher is the price, the higher is the output. Okay. So this is called the expectations augmented Phillips curve. So of course the Phillips curve is a relationship between output and or price and unemployment, or inflation and unemployment, and employment or unemployment. So this is a different way of writing a similar thing. It's called the Phillips curve in the book, so I'm just repeating it, but it's the relationship here between the price level and the level of average output. Okay. Yeah, and just I've written it here, but this is important. So this p down here, it's p relative to the expectation of p. So it's like the surprise in the price level. So why is this a Phillips curve? Right. So here's inflation. P is inflation. And y here is something that looks like employment because the production function of this economy is just L. So when y is higher, L is higher. So there's more labor in the economy. So you could think of this as a Phillips curve relating price level or inflation to labor supply or employment. Okay. So that is that. So here we go. There's our Lucas aggregate supply curve, price and output. We have an aggregate demand curve that's going to relate output and price. So our equilibrium P and Y, they're going to be given by combining. Let's just substitute out Y here. So we're not going to be looking at this anymore. We're going to be looking at P and M. So let's replace the Y with M minus P. And then we're going to solve for P first. So if we take this expression and solve for P, we get this expression. You can just do it quickly. We're going to get BP plus 1, or plus P if you like. I'll write this nicer. We're going to get BP plus P is equal to M plus B times expectation of P. Okay, just solving this thing here. So we can rewrite P is equal to 1 plus B, M plus B over 1 plus B EP. Okay. So once we've done that, now look up here, we've got little y is equal to M minus P. Let's just use our new expression for P here, substitute that in. Little y is equal to M minus 1 over 1 plus B times M minus B over 1 plus B expectation of P. All right. Combining these two, 1 plus B minus 1 is just going to be B. That's going to be B over 1 plus B M minus B over 1 plus B expectation of P. Okay, so this is the solution for, so what are we doing here? We're inserting money into the economy here. We're seeing how our equilibrium is going to depend on money. Okay. So this is just recopying the equations here, 4 and 5. All right, so let's take expectations. So here we've got an EP. We're going to say, what is the expected price level? Okay, so we're going to take the expectations on this side and the expectations on this side. By the law of iterated expectations, the expectation of P is just equal to the expectation of P. Okay. So we're going to get that expectation of P is equal to 1 over 1 plus B M plus B over 1 plus B expectation of P. Okay, put this on the other side. So we're going to get, let's see here, 1 plus, so it's going to be, well, okay, so over here we're going to have 1 plus B divided by 1 plus B. We're going to be subtracting off B, so we're going to get 1 over 1 plus B times expectation of P is equal to 1 over 1 plus B M. Oh, there's an expectation there, isn't there? Let me rewrite this so I have the right thing on the slide here when I save it. Of course, people don't know exactly what the money supply is going to be like tomorrow. Okay. So here we get 1 over 1 plus B times expectation of P is equal to 1 over 1 plus B times expectation of money supply. Cross these guys out, and then you get this. Oh, excuse me. Sorry about that. That was just my mother Skyping me. All right, so let's see here. Yeah, so this is how we derive this expression here, which sort of makes sense. It says that the expected price level is just the expected amount of money in the economy. Okay, so let's substitute in this expectation of money supply in for the expectation of price level here in these two equations, and then we can just write them this way. So you might say, wait, this seems like we're missing one more thing here. That's true. We need to subtract off and add 1 over 1 plus B times EM. So I'll show you how you do this here. So P is going to be equal to 1 over 1 plus B M plus B over 1 plus B. Now it's expectation of money supply. And now I'm going to add and subtract 1 over 1 plus B times EM. So plus B over, excuse me, not B, but 1 over 1 plus B EM minus 1 over 1 plus B EM. Okay, and what you'll see here is that I've got a 1 over 1 plus B times EM. Here I've got a B over 1 plus B times EM. When you add those two together, you just end up with an EM. So let's do that here. EM. Okay, so that takes care of this term and this term. Now here I've got an M and an expectation of M with the same coefficient, so I can actually just add 1 over 1 plus B M minus EM. Okay, so that's how we get this expression. We can do something similar here, except for it's a lot easier because we're just replacing expectation of P with expectation of M, and notice these coefficients are already the same, so these are very close. And you know, what does this mean? What's the point of doing this? Well, check out what we've got now. We've got it so that if the government prints money or destroys money relative to what was expected, it's going to both affect the price in this model and also the output level. Okay, and I'm going to talk about, how does it affect the price? How does it affect the output level? Well, there's some intuition behind that we can talk about here. Okay, so pre-announced monetary money shocks don't do anything in this model, because if M is equal to expectation of M, this goes away, and then the price is just the expectation of M. And then here, if M is just the expectation of M, if there's just a pre-announced money supply change, then you can see that it's not going to have any effect on output. Okay. However, so expected changes in the money supply affect prices, but they don't affect output. Expected changes, unexpected changes in money supply affect both prices and output. That's what you gotta know from this picture. And this makes sense because rational agents aren't surprised by sort of systematic policies. It's only sort of unexpected surprises that are actually going to affect output. If the government prints twice as many kroner, well, agents just know that, people know that prices are just going to go up. They're just going to double, right? I mean, there's nothing special about kroner. What really matters is at the back of the economy, you have demand, you have supply, you have a certain number of machines and a certain amount of labor and a certain amount of a certain type of technology that allows you to produce a certain amount of stuff. So fundamentally, the economy doesn't really have any connection with money. It doesn't matter if we're using yen, which is measured in the tens of thousands, or if we're talking about kroner, which is measured in the tens, or if we're talking about euros, which is measured in the ones or something like that. It's just a unit. It doesn't have any real meaning. Okay, so how do we think about the slope of this Phillips curve, right? So this is going to be critical. We want to think about how this relationship is between y and p. Like, what's the slope of this line? Okay, so if you recall, we had, I believe the formula looks something like this: gamma minus 1 times VR divided by VR plus VP. Okay, so this was B. Now suppose that, I should have stopped. I think I went on a little bit too long here, but suppose the gamma was equal to 2. Well, you can see here that 2 minus 1 is 1. This drops out. Eta, that's a parameter we haven't talked about for a while, but that's in the demand. It's the substitutability of goods. Okay, let me actually just pause here and we'll start a new video.